Okay, go ahead, Chris.
Yeah, it's related to the sun.
Okay, so you're going to present now, are you, Chris?
Yep. Yep. I can get some thoughts on this problem too. Problem or a perspective or just the way it is. It's not necessarily a problem, but it's a study in optics and the sun. Yeah. So these are photos, and these ones aren't photoshopped. They're single shots, and they're not time lapse. They're just single shots with the filter on them. From a couple of friends of mine. Different filters, but they're both just regular, standard camera shots of the sun. Now Bradley, he got in his shot, you can see he caught the sunspot roughly at 3 o'clock. It's almost perfectly at 3 o'clock, right there where my little hand is. If you can see my little pointer.
Yeah.
And then 3.5 hours later, he went back and took another shot. Didn't move the camera, just clicked it again 3.5 hours later. And now the sunspot has moved down to about roughly the 4 o'clock position, roughly 4:20, somewhere in there. So that's where I've circled those two locations of the sunspot. I was trying to do some measurements on the grid to see where things were lining up. Now he is in Montana, so he's above the equator in Montana in the United States. And I have another friend that's a great photographer also, and also does a lot of pictures, and he's from Sao Paulo, Brazil. So he's south of the border. And his pictures, his name is Anderson Navies, if you want to go check out some of his pictures too. His photos are the opposite. His sunspots start on the left and tend to go down to the right down towards 6 o'clock. So over time, these ones are over time. So this one is 9:24, and then 12:16, right, 14:22, and you can see that the spot just travels from the top of the clock down to the bottom of the clock. The sun's acting like a giant, a really big clock in the sky, right? But it's interesting that it has the same properties that we see in the moon. When you cross the equator, it flips. Right?
Yeah.
But it seems to actually...
Also what the big difference was in the photos you showed before, the sun was far more elliptic.
This particular equator itself, or the actual position between the...
Oh, is it just because of the internet? Can you go back to those photos where you can see those two beside each other?
Well, that's probably because I had them slightly tilted. I probably did that. Yeah.
Yeah, because
yeah,
it almost look like they are elliptic from. That's the,
yeah. This is his original photo, and in this one here, I put them into some software, and I was trying to get some measurements, so I probably just rotated it backwards.
It's just a little bit more oval shape.
Yeah. The thing I'm looking at though is north of the equator in the United States, the sunspot goes in this direction from the top on the right-hand side of the clock down to 6 o'clock, and then south of the equator, it goes the other way. And I know that Robertson's are taking pictures, and Dave Marsh is, expert on the moon and timeanddate.com, and we've looked at that moon flip phenomenon too, where you can have two people take a picture of the moon at the same time, one in the north and one in the south, and the image will actually flip, but they see the same face, right? With the same craters, the same face. So you would think that if you were traveling, say, from Atlantic Canada, took a picture in Atlantic Canada, and someone in South America took a picture at the same time of the same moon in the same time zone, you would think that if it was an orbital, like an orb object, then from those two different perspectives, you would get a slightly different image, right? You shouldn't see the same craters because it's like you're walking under a big basketball. that type of idea.
Yes.
There should be, you know, because it's so, in theory, it's so far out there, you wouldn't get a whole lot of parallax in the image. You know, maybe a half a degree or a degree or two, because it's a very
Can I
distant
ask you
object.
something? Is the picture supposed to look like that? It's a bit pixelated.
Yeah, it is. Yeah, it's a high zoom picture with the filter on it, so it's.
Just checking. Okay, thank you.
And I think when I share screen, because I'm sharing from Facebook here versus
Yeah,
pixelation.
because
There,
downgrades your image, definitely.
yeah. Yeah, it's just to show how that image is traveling. But what I noticed, so the best way to explain that is, it seems to be. Now you can correct me if I'm wrong, but I'm not sure if the moon flip is more of a vertical flip, and the sun here appears to be doing a horizontal flip. You know what I mean? Right, if you take a picture of the moon in the north and one in Canada, one in Australia, the two photographers will get an image that's actually vertically flipped. It'll be a reverse image of the same image, but one is facing up, but one's facing down. Right, so it's an upside down. But in this case,
Oh, but
the sun is going,
right.
is flipping in the opposite axis. It's flipping on. So that would be. So let's say that's the moon is a flip on the x-axis. This is a flip. This is a flip, and the sun is a flip on the z-axis. And that just
Oh,
kind of
that's
makes me say again. Right. I mean that just went so far over my head that I'm like, what is going on?